Good morning, guys.
Good morning, sir.
Very good morning. So far, any doubts from yesterday's session or yesterday's session? I mean, regarding the robotics, all these things. Clear? Or you want to me revise all those things once again? Everyone, is it clear so far?
Yes. Sir, you are right.
Okay. Sorry. So, is it clear? This configurations, classifications, is it clear? How the moment will be according to the moment? How they will be classified? Is it clear?
Yes, sir.
Okay. Next one, these joints, if it is a rack and pinion joint, then how the joint will be, what exactly we are going to call. If it is a supporting hinge joint, then what exactly we are going to call it as a. If it is a twisting joint, so what is the thing we need to involve for a twisting joint, and for a revoluting joint, what is the thing involved here, and what is the examples. Clear in this also?
Yes, sir.
And degrees of freedom. So if it is a hinged support, or if one end of the particle is fixed to a part, then there will be having only 1 degree of freedom. Similarly with this also, if it is a spherical joint, then automatically it will be having all the linear movements constrained, whereas there will be having 3 degrees of freedom on the revolution side. So we'll be having some 3 degrees of freedom in the revolutionary joints. And coming to this point to point as well as continuous. So point to point and continuous both are used for robotic movement only. So based upon the end application, we are going to define which path we need to follow, or which system we need to follow. If it application is preferring at each and every point, which means that the robot need to stop at each and every point, then I will go for point to point, where what will be happened, my robot motion will be constrained, will be coming to rest at each and every position, and the operation will be performed. That is what exactly happen in the point to point. Whereas in continuous point, what will be happen, the robot will be continuously following the line, it won't stopping. So this is called as a continuous path. So these both will be differentiated with with respect to the examples, I mean with respect to the applications. So if it is a spray painting, then we are going to pick this one. If it is a welding, we are going to pick the continuous path. Other than that, if it is a spot welding, or if it is somewhat cutting or drilling application, then we are going to use the point to point application. Both systems will follow two different systems, coordinate systems, that is absolute coordinate system as well as incremental coordinate system. In absolute coordinate system, every point will be taken 0 0 as a reference, that is absolute coordinate system. Whereas in incremental coordinate system, what will be happen, the first point will be taken 0 0 as a reference, whereas the next point will be, what is the next point? So if I am considering B point, then A will be supposed to be the reference for, I mean reference point for this B. This is what exactly happened in the ICS. So based upon these two, I mean based upon the user skills, they can pick either ACS or ICS. Both are doing the same application. Based upon the number of points, based upon the application, they will choose according to this one, whether they want to go for absolute or whether they are going to for incremental. That depends upon the user. Okay. Now, so as I said, P2 point is a compatible moving in one point to one another direction. Mostly it is used for insertion, spot welding, hole drilling, mission loading and unloading assembly operations. Whereas continuous path is capable of moving continuous path in a controlled manner. At the same time, straight line will also be one of the key aspect here. And while coming to the application, there are spray painting application, finishing, gluing, and arc welding. These two are the major applications, spray painting and arc welding. Whereas what will be happen, the continuous process need to be adopted here. So at this point, continuous path will be used as a beneficial one. Whereas in the previous, other than these examples, like spot welding, drilling, assembly application, machine loading and unloading, inspection, all these things will be go for this point to point. Okay, while coming to the technical features on some of the important aspects of the robot, where first one is a work volume. Work volume is nothing but if a robot is here, and the area with which the robot is going to cover is known as a work volume, or in other words we'll call as a envelope. Both are correct. Okay. which means the robot working area. Second one is precision of movement, means how precisely the robot is moving, how much accurately it is moving. So after 1,000 runs, what will be the precision, whether it is reaching the given point or not. So is there any delay or not, whether there is any defect or not. So that can be done by this precision only. Next, speed of the movement based upon the robot movement, based upon the end application. If the end application is having, somewhat higher weight, then the robot need to do the application in somewhat lower speed. If the end application is somewhat lighter, then the robot can do the speed at a moderate speed. So like the based upon the end application, we are going to define what type of speed we need to require for the robot and for the application also. That is what exactly speed of movement. Next, weight carrying capacity is nothing but the payload, the maximum load which the robot can pick or lift. That is called as a weight carrying capacity or a payload of the robot. So if a robot need to pick some chassis from the base or from a conveyor, then the robot must have some large robot should be needed, and it's supposed to lift some 20 kg or 30 kg of load. Then the robot should be having a payload of 20 to 30 kg or some more than 30 kg. Then only it will supposed to lift this part. That is what exactly weight carrying capacity. If the robot is using some pneumatic as a source, then the robot must or the robot tend to lift only up to 2 kgs or less than 2 kgs. Then what will be happening here, the pressure that will be generated by the pneumatics will be low. So what will be happening here, the weight carrying capacity will be low in this type of robots. So based upon the application only, we are going to describe what type of robot is needed and how much a payload should be needed for that robot. That is one of the axes. And type of drive system, similarly based upon the end application. If the end application is a glass, then yeah, that need to lift from one place to another place. Or end application is a sheet metal, simple sheet metal that need to pick and that need to place in this hydraulic press. That, and then the applications based upon the weight. So we need to define what type of drive we need to need it, whether we need a vacuum one, whether we need a hydraulic one, whether we need a motor. That can be defined based upon the end application. Now coming into today's session. In today's session we are going to discuss about robot selection, which means if at all we are going to purchase a robot, or if at all you want to involve a robot. I'm having an industry. In my industry, there is an application. In that application, that I need to pick the sheet metal. This sheet metal is having weighing mostly 1 kg of weight and dimensions like 50 centimeters by 50 centimeters of square. Okay, square sheet. So the robot need to pick this one and place in this hydraulic press. So the next part, the operation will be, there will be having some dents or there will be having some hood with that will be created. That is what exactly application. Now for this application in my industry, I am having 10 different robots, so with different capacities. Like, so one robot is having 1 kg of payload, robot is having 2 kg of payload, and one robot is having 20 kg of payload, one robot is having 30 kg of payload. Other than this, I am having four more robots. One is two is for hydraulic usage. The two robots are using hydraulic as a medium. Two robots are using electrical, which means servo motor or a motor for this application. And there are three other motors that are used pneumatics as their input. Now out of these, 1 2 3 4 5 6 7 8 9 10 11, out of these 11, which configuration I need to pick? So this is a servo, this is hydraulic, and this is pneumatic. Which one I need to pick for this application? The weighing application, the weight of the component is 1 kg only. So I need to pick material here, I need to place here. So which robot I need to use here out of these 11?
So 1 kg.
Yeah, 1 kg, the maximum. This one is 1 kg of weight. Now which robot I need to choose out of these 11? I mean which section? Whether I am going to go for a servo or a hydraulic or pneumatic, which application is somewhat better?
Pneumatic, sir.
Why pneumatics? What will be happen if I use this hydraulic here? So let us take an example. If I use
हाइड्रोलिक
hydraulics,
तो सर जो ज्यादा भारी चीजों के लिए यूज किया जाता है, मीन्स ओवरलोड के लिए.
okay. If it is 100 kg, then we can lift it by using hydraulics. If it is a 1 kg, we can do the operation. But what will be happen? There is a lot of wastages, lot of facility wastages, loss of resource wastages will be there. That is why to eliminate that. So this one is not considering. Now what will be happen if I use a servo? I mean, if at all I am using a motor, electrical, what will be happen? Same application. We can use this, but what will be happen? There will be a lot of wastage. This electrical wastage will be there because the weight is of 1 kg only. Okay, these motors will be generally used for 5 to 10 kg of margin. So in this case, what will be happen? There will be again a resource wastage will be there. So to eliminate that, I am going to pick the pneumatics where it will be designed for less than 2 kg. My end application is 1 kg only. So in this application, I can go for the pneumatics. Like this, I can choose. So not only in this section, there are a lot of things that will be considered for selecting a robot or for purchasing a robot or for giving application to the robot. These are the some of the things. Okay, robot selection. Once the application is selected, which is a prime objective, a suitable robot should be chosen from the many commercial robots out available in the market. Now, these robot selection will be depend upon these 10 capacities in 10 characteristics. The characteristics of the robot generally considered into the selection process include: first one is size or class, second one degrees of freedom, velocity, drive type, control mode, repeatability, lift capacity, it's a movement, wrist movement. This is a wrist movement, and this is a body movement, robot movement, and weight of the capacity. All these things will be depends on robot. Now we will see each and everything in detail. First one is size or class. The size or class of robot is given in the maximum dimensions. In the previous example, I have said that I am having a plate, so which is 50 centimeters by 50 centimeters, like this. See, if it is a micro volume, I mean the robot is there, the robot area, how much area it is going to cover. So based upon that, my robot size will be defined. Now I need to pick this much of weight, 50 kg. Now see here, micro robot is like, so it should be less than 1 meter. The work envelope should be less than 1 meter. It means if this is a 1 meter area, so I'm going to do this only 1 meter area, then I need to go for the micro robot. So there is a small that is range for 1 meter to 2 meters of work envelope. So there is a one more thing, 2 to 5, that's called medium, and large is more than 5 meters. So based upon the work volume, which means the diameter of this work volume, so we can the robots will be classified on these things. That is first thing. Okay. Second one is degrees of freedom. Degrees of freedom is nothing but I have already explained you. See, the cost of the robot increases the number of degrees of access. 6 degrees of freedom is suitable for most works. As I said, RRR, articulate robot, is the most commonly used 6 degrees of freedom. Now generally this is the most widely used application, I mean most widely used robot in the industry or in the market. So now what will be happen if at all my robot need to do some other additional application, then I will go for the Puma or Scara based upon the application. So generally these will be having 6 degrees of freedom. So if at all I want to go additional degrees of freedom, then I am going to purchase this articulate robot, and additionally I want to add some conveyor or some belt or something. So to define extra motion, that is what exactly defines based upon the movement. So we are going to consider what type of robot I need to use, whether I am going to use a 6 degrees of freedom. 6 degrees of freedom in which direction, whether in a rotational direction or in a linear direction. So if it is a combination of linear and a spherical, so how exactly I need to define that based upon the degrees of freedom. Okay. Next one is velocity. Like already told you, like velocity is like a speed, how much speed it is maintaining. So velocity considering the effect with the robotic arm structure, rectangular, cylindrical, spherical, articulated robots, which means nothing but each and every robot will be having certain speed. If it is a linear robot, see, let us take an example. There is a joint here, okay, and my robot arm is like this. Now in this application, the robot need to pick a part here, and it will go into place here. In this application, if the velocity is more, if the velocity is 5 kmph, then what will be happen? Just a second, let me give you in clear. This is my robot, okay, and this is my linear joint, and need to pick a part here. Now see, this is the movement. The robot tend to move to this direction. If this distance is somewhat, let us take an example of 50 centimeters. 50 centimeters of movement is there. Now this movement, if I give 5 kmph, then what will be happened? What is the distance the robot is going to cover here?
50 centimeter.
50 centimeters. So 50 centimeters it is covering. The arm of the robot, the length of this arm is somewhat 200 centimeters. Now when compared to this, what will be happen? This is one fourth part. So when the robot is going to cover this 50 centimeters part, what it need to generally the initial velocity vi. What is initial velocity here?
Zero, sir.
Yes, initial velocity will be 0. Now what is the maximum velocity that it need to cover? Velocity maximum
5 kilometer per hour.
5 kmph. Again, what will be the maximum, what is the output? I mean, what is the exit last velocity? Again, final velocity vf. What will be the vf final velocity? Hmm? Sorry. Is it clear? First initial velocity is 0. Why? Because the robot is in a static condition. The robot initial velocity is 0. Now what is the maximum velocity I am going to cover here? So I have given 5 kmph is the maximum velocity that need to cover. So once it reaches this position, this is I and this is F. Once it is reached the F position, what will be the velocity?
It depends on its acceleration.
Again, it is coming back to static condition. See, it's a point. Let us take an example of point to point or continuous path. What will be happen once it is reached its final position? Then it can't. I mean, at 5 kmph speed at the maximum condition, what it will do? It won't do anything. So it need to stop at some condition. So initial velocity is 0 and final is also 0. So once it condition this, I mean, once the robot is reached to this condition, again the robot velocity is 0. So it will be going to stop. So in between there is a 50 centimeters for increasing, I mean, for it need to catch this speed. Now what will be happen? 50 centimeters, in 50 centimeters the robot need to pick 5 kmph speed. Okay, again instantly it need to come to 0. Now what will be happen? See here, 0, 50, 0. I mean, this is the 50 centimeters. Now again starting from 0, 5 kmph and 0. Now what will be happen in this condition? There is, the robot need to follow this much of speed in a 50 centimeters. In the 50 centimeters itself it need to accelerate and deaccelerate in 50 centimeters itself. So because of this, what will be happen? There is a limited space here, I mean limited envelope here, because of which what will be happen, there will be sudden jerks will be happen. Because of sudden jerks, what will be happen, there will be a damage in this joint. So that is why based upon the end application we are going to finalize this also. So what is the maximum speed? How much speed I need to weather? Here in this application, 5 kmph is not at all acceptable. If it is a 1 kmph, maybe it is acceptable. If at all I am the programmer, I am going to give, then I am going to give some 0.5 kmph or 0.25 kmph. That much less. Why? Because there the area that is going to cover is 50 centimeters, hardly 50 centimeters. So here I am going to maintain some sort of some smooth speed. What otherwise, if at all I give the 5 kmph, what will be happen? Instantly it will go pick this one, and once it reaches the 5 kmph, initially it will going to deaccelerate. So because of sudden, what will be happen? There is this much of graphs will be there, because of which what will be happen? There are the gears that will be involved in this rack and pinion that will going to damage because of the sudden jerks or because of the sudden brakes that are going to apply in this motor. That is why based upon the end application we are going to define what type of velocity that robot need to maintain. So if at all I'm using 50 kg of payload robot, for 50 kg of payload, it doesn't, I mean, the robot doesn't need 5 kmph. Why? Because it is itself picking some 100 kg or 50 kg of load. So it should be having limited speed, it should be having low speed to reach the final destination or to maintain the precision or accuracy. So based upon that, we are going to define what type of velocity that will be needed, how much velocity is the maximum that is needed for that robot. That we need to define based upon these two things. Again, these two are interdependent. Next one is the drive type. So just a second, let me erase this. Drive type. Drive type is nothing but hydraulic, pneumatic, electrical, and electronics. As we have discussed, hydraulic is nothing but for maximum applications, pneumatic for lighter applications, electronics are defined for moderate applications. Based upon again the end application, this is the classified. Next one is control mode. Control mode is nothing but how exactly we are going to move the robot, how exactly we are defining the robot in a particular manner. That is what exactly control mode. Either it should be a point to point, either it may be continuous path, or sometimes we call it a controlled path. Controlled path is like a manual. So if at all you are running the continuous program, I mean the program each and every cycle you are running manually only, then we call it as a controlled path. So these two are automated. So once you have to define the program initially and you have to make a test run. Once it was running perfectly, then you have to run it for up to your extent. So if it is 100 number of cycles, okay, it's up to 100 number of cycles. If it is 1,000, you can run this 1,000 by directly giving n equal to 1,000 directly here. Whereas in control path, what will be happen? Even the 100 cycles you need to do manually. That is called as a controlled path, which means you are going to monitor the path. You are going to monitor the robot continuously, or you are giving the commands at each and every cycle manually. That is what exactly controlled path control. This is called as controlled mode. After that, as said again, lift capacity. So based upon the end application we are going to perform, how the lift capacity will be. So if the payload is having 0 to 5 kg or 5 to 20, 20 to 40. So this is what exactly the lift capacity will be defined. So this is called as a payload. So we'll call as a payload of the robot. Okay, next one is repeatability. Repeatability is that the ability of robot repeatedly position itself when asked to perform a task multiple times. Accuracy is an absolute concept, repeatability is relative. The robot that is repeatable may not be very accurate or vice versa. Now, can anyone explain me what are repeatability and accuracy? Both are same or both are different? Can anyone explain me this? What is the repeatability factor as well as what is the accuracy? Or is the repeatability and accuracy are both, or they will be differed? Repeatability and accuracy.
So repeatability can be said as precision, and accuracy means the closeness to the actual value, and repeatability means the all the values are close to each other, but it not may be close to actual value.
Yes. Okay, fine. That is correct. Repeatability is nothing but, see, if the first point is reaching this position, second point is reaching this position, third point is reaching this position, fourth point is reaching this position, even though the robot need to place the part here. So this is the final. Okay, this is the final place. It need to place, but the robot is picking the parts and placing here continuously. See here. Just a second. Yes. The robot is placing the parts at each and every here continuously. Then I will call this as a repeatability factor. Accuracy is nothing but the robot need to pick a part and it's supposed to be placed at this position. This is called as accuracy. Okay, at this position is accuracy. Clear? Repeatability is nothing but even the robot is not reaching, even though if it is reaching this part, even though if it is reaching the final position and maintaining the final position with a 1 mm or 2 mm tolerance, that is called as a repeatability. So whereas not at all maintaining is, these are the two different things. Okay, I will explain you here. Where is this? Okay, so there is a slide that will explain you what exactly repeatability and accuracy. In that I will clearly explain you what are these two in detail. Okay, now coming to this one, manipulator. What are manipulators? I have already explained you in a number of terms. Arms, okay, fine. Manipulator is nothing but electromechanical device capable of interacting with environment. So manipulators, links, arms are both are, all these are same. So which are connecting devices of a robot. So if a robot is having some 6 arms, so which tends to do some application, then we will call these as a arms or manipulators. The connecting parts or the holding parts of a robot is known as a manipulators. Anthropomorphic, what are these? Like human beings. See, the name itself indicating anthropomorphic is nothing but human. So human related. So nowadays what will be happening, there are a lot of robots that will be prepared like humans. So in general they are called what are those? No. Anthropomorphic is a technical word. Recently they are using some word to describe this one. So if the robot is just similarly with this human behavior or human like structure, then we will call as anthropomorphic values or anthropomorphic robots. Okay, and effector is nothing but our wrist. So where we are going to hold the part. So if there is a manipulator is there, so manipulator is like a elbow, so the final part need to be added here. This is called as a wrist or end effector. Okay, so the tool or gripper or the mounting device at the end of the manipulator for accomplish various number of tasks, that is called as a end effector. Now we will coming into one of the important topics, that is called as a robot grippers. Like already we have discussed, like for holding the parts. So if at all I'm having some mechanical component, if at all I'm having some mechanical sheet metal, so if at all I want to pick that material and place it somewhere, place on the mission, then how can I supposed to pick it? Okay, so if there is a iron bar is I mean block is there, so this is the block. So if this is the block, how can I supposed to lift it? If there is a spherical like workpiece is there, how can I supposed to lift it? If it is sheet metal, how can I supposed to lift it? If there is a glass is there, I mean there is a thin glass is there or thick glass is there, glass plate is there with some 5 centimeters of thickness. How can I supposed to pick it? That can be defined these grippers. So there are different type of grippers like pivot action, slide action, double gripper, and vacuum operated. Pivot action grippers are like these things. Then what will be happen here? There will be a hinge support. With this hinge support, this will be moving this in this direction. Both will be working simultaneously, so that whenever an operation was done, so automatically they both come closer. So when they both come closer, so automatically the part that will be here, that will be holded here. Okay, generally this gripper will be used for this any type of mechanical components or a solid components where there is a no worry for the scratches or anything. Why? Because there are sharp edges will be there and there will be having lot of dents. Why? Because it is holding this part with lot of pressure. That is why there will be having some dents that also will be observed in this component. So at the applications we are going to use this type of grippers, that is pivot action. So where the hinge support is, because of the hinge support we are going to pick the part. Second one is slide action grippers. So both are same. Here we are using a hinge support so that it will be act as an angle, it will be act as a corner from which the object will be holded. Here what will be happen? We are using some sliding action so that what will be happen? This will be coming directly like this in this direction, horizontal direction, so that it will come here and it will hold the component. Okay, they both are same, but here just how exactly it is going to move, that is differed here. Here we are going to use in support, you are going to use a sliding action grippers so that it will be sliding on the given path. Third one is double grippers. So based upon the application, if the robot tend to other, if the crane or if the robot tend to lift the part at multiple locations or pick the part at multiple locations, then we are going to use a double, triple, or there will be having more number of these things. Then we are going to use this type of grippers. If it is if the component, if the final component is smooth in nature, or the weight is less than 1 kg or 2 kg or 5 kg and it's supposed to maintain the surface finish, then at that point we are going to use the vacuum operator. So that what will be happen? So there will be a pneumatic source, it will be going to press here and it will be holding. Once it was recreated, then automatically it will hold the component. Based upon this, it will pick the component and it will place at the desired location. Once the location will be reached, again it will be releasing pressure. So once the pressure will be released, automatically this part will be released from this vacuum gripper. So this is one of the important type. This is one of the mostly used common type. If the application is less than 5 kg or less than 3 kg, or at the if the surface of finish that need to be maintained, then these type of grippers that need to be definitely used. Okay, now coming into workspace. Like already told you, workspace is nothing but envelope. Robot envelope is nothing but a workspace or a work volume. So where the robot is going to cover the area. So what are the different areas, how much area it is going to cover, that will be defined by this workspace. The volume in the space that robot and effector can reach, both in position and orientation, that is a workspace. It will be depend upon position, orientation, links and joints, different things. Okay, next one is this one: kinematics, dynamics, actuators, and sensors. Kinematics is nothing but, what is kinematics? According to you, what is a kinematics?
So study of the motion.
Hmm?
Kinematics is study of motion without considering the forces which are causing the motion.
Okay. Any example? See, if there is a link is there, let us take an example. There is a link here and there is a joint here. They both are connected here, freely connected. So it can move all the direction. Now, what is kinematics in this application?
Or the velocity with which this arm is moving.
Okay, velocity with which, here in kinematics generally we are not considering the velocity. Here the, see, simple example, kinematics nothing but there is a beam here, beam or component here. The movement of this component along its work volume is known as kinematics. So how much area it is going to cover, on what direction it is going to cover, what is the As you said, velocity. At what velocity it is going to cover, all the things will be covering in the kinematics. The movement of a component in its work volume or in its space is known as kinematics. Okay. Clear? Just observe your hand. What will be happening from the elbow section? So if you are going to move your arm continuously, so the work volume that is going to cover, that the work volume that is going to reach, at the same time how much speed you are maintaining, what is the maximum conditions, what is the maximum conditions of your elbow to move in the envelope, is all things will be called as a kinematics. Then what are dynamics?
Study of motion with the consideration of forces.
See, kinematics and dynamics both are same. Only thing is here we are going to test the component, or we are going to work the component with zero force. I mean with the self itself. If the body is having 1 kg of self weight, so now we are going to test the component with 1 kg of self load, then it is called as a kinematics. If the robot is picking, I mean if the arm is picking or if the application is picking somewhat weight, I mean which is more than its self weight. So if it is picking some 2 kg of load, or if there is an automobile is there, the automobile is picking some 10 kg of load and it is going to move from one direction to another direction, then we'll call it this as a dynamics. If the robot is picking a component and it is going to move complete envelope, it is going to move the complete work volume, then we'll call it as a dynamics. If there is a no weighing, no extra weight is there, then we'll call it as a kinematics. Okay, kinematics is nothing but study of motion without having any force in it, that is kinematics. Same application, the study of motion with respect to force, is nothing but dynamics. Okay. In robot we are going to work on both. So which means, so what will be the kinematic behavior of the robot if it is not having any weight? Now what is the maximum velocity it will be reaching? Okay, so if there is a robot is there, okay, a robot is there, the robot and itself is having this much of envelope, and there is having some v velocity, x moment, everything will be having. Now without having any weight involved here, so what will be the maximum conditions, what is the condition that is going to maintain? So what is the speed, how much time it is going to take it to cover 360 degrees, so what is the maximum distance it will going to cover? So all these things, testing all these things without having any force, is known as kinematics. So if at all I want to check the end application is picking a chassis, okay, and it need to do the application. Now in the test run, I am going to pick the chassis and I am going to calculate all the things it's going to perform. Now that is called as a dynamics. Now I will going to compare these two. What is the kinematic behavior? What is the dynamic behavior? So I am comparing here. So after picking this much of 5 kg of load or 50 kg of load, so what is the maximum speed that is maintaining? So with what is the maximum speed that I am going to give? So at the given speed, what will be the movement of the robot? What are the degrees of freedom that is constraining? What is the errors that I'm going to maintain? Whether it is going to meet the accuracy or not? Whether it is giving any repeatability factor or not? Whether it is moving in accurate path or not? All those things I am going to check in the dynamic behavior. Why? Because the robot tend to move in the dynamic environment only. Initially, the robot will going to work, or we are going to program the robot in a kinematic environment. So once the kinematic environment is done, once we will be having the values of kinematics or robot kinematics, then definitely we are going to jump into dynamics, where we are going to test the robot with the workpiece which we are going to do, or which we are going to perform. That is what exactly dynamics. Okay. And in the dynamics we are going to check the maximum conditions also, just like the validation. In plant simulation, what will be happen, we are going to check the maximum conditions, like in the dynamics also we are going to maintain. So after picking 50 kg of load, that is a chassis, then what will be the maximum condition? So what will be happen if I give zero point 0.5 velocity, zero point 0.5 kmph? What will be happen if I give 1 kmph? What will be happen if I give 1.5, 1.55 or 2? So I can check it different levels, so that this will be the maximum value. So I am giving instructions to that, so that the robot need not exceed this 2 kmph, or it tend to maintain the 1 kmph for a smoother run, for maintaining repeatability factor. Like I need to maintain different dynamic validation conditions. At what condition the robot is going to fail? What will be the maximum condition at which I am getting the maximum efficiency? At what condition I am going to get the repeatability factor? At what condition I am getting the accuracy? Whether my repeatability and accuracy both are same or not in dynamic conditions? Those things are going to test in these dynamic environments. So clear regarding these two.
Yes, sir.
Okay. Actuators are nothing but the driven mechanism. Sensors, reads variable. Okay, regarding the sensor also I will give you a brief when coming into the next slides. So why exactly we are going to use sensors? What are the different inbuilt sensors? What are the additional sensors? What is the use of sensors? All those things we'll be discussing in the coming slides. Next one is speed. Speed is nothing but the amount of distance per unit time, so which the robot can move, usually specified in inches per second or meters per second. The speed is usually specified at specific load, assuming the robot is carrying a fixed weight. Actually, speed may be depending upon the weighing carrying of the robot. As said, speed. So how, what is that speed that need to maintain? What is the kinematic speed? What is the dynamic speed? So what will be happen if I use 5 kmph at initial velocity? What is the what is the what will be happen if at all I am using 5 kg or a 5 kmph speed after picking some 50 kg? Like I need to check different aspects in the speed also. So every robot will be defined for some 10 kmph or 20 kmph of speed, maximum speed, based upon the end application. Maybe the some application is preferring high speed, then at that condition what will be happen, this speed will vary, this speed will matters. Some conditions will give that the speed is doesn't matters, at that condition there will be using some 1.1 kmph or zero point 0.2 kmph, like. But every robot itself is having some 10 kmph or 20 kmph inbuilt in it. But what is the speed which we are going to maintain? How much speed we are going to maintain that for application? What will be the perfect application? What will be the perfect speed for my application, that I am going to validate my robot based upon the speed also. Like different scenarios. At point 5, what is the robot behavior? At 1, what is the robot behavior? Now I need to judge, I need to create a controlled, I mean complete report for the speed also. At each and every moment, even point 0.5, point 0.6, point 0.7, the robot operators will going to collect this every information, like what will be the behavior of robot at point 0.9. So what is the robot behavior at 1 kg? So what is the robot behavior at 1.1 kmph? Like the robot programmers or robot engineers will going to collect the robot validating reports at each and every speed, so that they will validate, they will going to analyze everything, and they are going to define one thing, I mean one particular speed. Again, in that one particular speed they are going to test all the feasibilities, like if at all the robot need to do this application, how much time it will be going to take. So if it this is the 5 minutes of time is taking for picking a part and placing it somewhere, so with which what is my rate of production, they are going to monitor the rate of production also. So because of which what will be the lead time will be, because of which what will be the cycle time, so what will be happen to the tag time, all those things they are going to maintain with respect to the speed of the robot only. Next one is lift capacity. In the previous slides, as we have discussed, based upon the robot weighing carrying capacity, this lift capacity will be defined. The maximum weight carrying capacity of the robots that can be carry, I mean the large weight that precise and expensive. Simply 0 to 5 kg, 5 to 10 kg, 10 to 20 kg, more than 20 kg or more than 50 kg, based upon the end application we are going to find. If my application is only 1 kg, now at this condition what will be happen if I use a 5 kg also? That is not acceptable. So at this application I am going to pick a robot that is weighing only 2 kg only. Like that I am going to search in the market that whether they are going to produce any type of bench robots or not, I mean prototype robots or not. So are small robots, micro robots that will be giving this 2 kg speed, 2 kg lift capacity, that will be giving or not. I can check like this different parameters, so with which I am going to, based upon my end application, I am going to select my robot based upon the lift capacity. Okay, spatial resolution and accuracy. Here we are going to discover, this is not a, I mean, not that much important. We will be discussing about accuracy and repeatability now. See, accuracy can be defined as the ability of a robot to position its wrist at the desired target within the reach, within its reach. In terms control resolution, the accuracy can be defined as a one-off of the control resolution. The definition of accuracy applies the worst case when the target point is between two control points. The reason of the displacement smaller in one basic resolution BCRU can be neither be programmed nor measured on average. So it depends upon the system control resolution of the robot mechanical accuracies. See here, robot is not, accuracy is nothing but ability of the robot to position its wrist at the same position, at the given position. Here, now I am going to pick a part. Okay, my robot is need to pick a part from the conveyor. Now for this application, accuracy is needed or not? Picking, now this is a picking application. The part is coming like this to a substance, the robot need to reach over there and it need to pick here by using these grippers. So once it was done, then it will go into subsequent operation. For this application, accuracy will be matter or not?
will matter.
How will matters? What will be happen if accuracy is not there?
So if your accuracy is not there, then in many cases it would not be able to catch the part or lift the part.
Okay, see here, I am using some sort of sliding grippers here, just an example. there is a sliding grippers. Okay, in the sliding grippers there is a gap of some 50 centimeters. Okay, now I am going, this part is having only 20 centimeters. Okay, now the robot will come like this. So this is my gripper. Okay, and this is the conveyor. So if the part is here, then what will be happen, the robot will reach here and it will be closing. If the part is here, the robot will go and reach it. If even the part is here, the robot will pick it. If the part is here, the robot will pick it. If the part is here, the robot will pick it. So this is called as a, I mean, this is the zone where what will be happen, the robot is picking the part, which means here for picking a part, accuracy is not matters. Why? Because what is the what is we call deviation, not deviation. Yeah, what is the tolerance here? So this is 50 centimeters and the part is 20 centimeters. What is the tolerance value here? What is the tolerance? There is a tolerance of 30 plus or minus 30. So with the tolerance of plus or minus 30, what will be happen in this region, in this 50 centimeters region, if the part is anywhere, the robot will pick it. This is called as a, I mean, at this application, accuracy is not maintained. For picking a part, accuracy is not a key aspect. Now, this is a picking application. Once the picking is done, I mean, once the robot has picked this part, now the end application is, this is the mission. Okay, and this is the vice, mission vice. This is 22 centimeter dia hole. Now the component is 20 centimeter dia. Now the robot is picking without having any accuracy. I mean, there is no need of accuracy at this application. Why? Because in this region, part comes anywhere, the robot will pick. Now, what will be happen if the robot is not maintain accuracy here? Here there will be having 50 centimeters of tolerance, because of which accuracy is not maintaining. So whenever there is a part, automatically the robot will pick because of the tolerance. Now, if the robot is placing a part here, is it acceptable? Yeah. If the same robot picking a part from this location and comes here, the robot supposed to place the component here in this 22 centimeters. Okay, after that automatically, because of some jigs and fixes, the part automatically controlled. If the robot is placing the component here, is it acceptable?
No, sir.
No, sir.
Even if it is placed like this, even if it is placed like this, these are all not acceptable things. Okay, but here what is happening, see here, these many components are placing at a simple, I mean, at a prescribed path in this given region, then we will call this as a repeatability, which means it is maintaining the same position, it is maintaining the same path with having 1 centimeter or 1 mm tolerance. It is meeting each and every point. So if the previous point is here, next point is here. Okay, next point is here, next point is here, next point is here, next point is here. See what is happening here. So there is a 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter of distance between these two. See, this is called as a repeatability. Okay, so maintaining the same distance or maintaining the same set of rule between the components, maintaining the same relation with the previous part, is known as repeatability. See here in this application, what is happened, repeatability is there. So it is, even though it is not maintaining the accuracy, but what is happening, it is going to place the component in the repeatability factor in the given region. This is called as a repeatability. Okay, it is the ability of the robot to position the end effector at the previous position location with plus or minus 1 centimeter or 1 mm tolerance. This is called as a repeatability. Now this is no way acceptable. If it is a CNC machine and I am going to perform operation, then if the parts are placing like this, which means the robot is having a repeatability, greater repeatability, but it is not at all maintaining the accuracy, which is not at all acceptable for this application. Now what I need to do here, this here and the same mission, and there is a 22 centimeter circle here. This is called as a 22 centimeters cavity is here. Now the robot need to place the component here anyhow. This is called as, if it is maintaining here in itself, in the cavity itself, then we will call this as a accuracy and repeatability. Both are same here in this application. Okay, reaching the same position, reaching the final position continuously even after 1000 cycles is known as accuracy. Okay, whereas repeatability is reaching the previous point with plus or minus 1 mm or plus or minus tolerance is known as repeatability. Clear?
Yes, sir.
Now see, in this application, this white circle, there is a white circle is here. Okay, in this white circle, the part need to place, the part going to place. Now in this application, this is a repeatability or accuracy. What is this
Sir,
thing?
both.
Yes, A, B, C and D. In this A application, what are we will be having? We are having repeatability and accuracy both or not. So we will be
Yes,
having
sir.
repeatability as well as accuracy. Guys, clear everyone?
Yes, sir.
What about the rest?
Yes, sir.
Yes, sir.
Yes, sir.
See, why? Because I'm continuously, once I have started presentation, I'm continuously going on my own. So if you are having any doubt, you need to stop me and you can ask, no problem. Why? Because otherwise what will be happening is some of the complicated things. Maybe if you miss something, again it will be carry forward for you for the next sessions also. That is why I'm just asking you. Okay, see, repeatability and accuracy in this application there. Why? Because in this component itself, the component need to be placed. See, all these points are placed inside this white circle itself and it is maintaining the same ratio. Then it is having repeatability as well as accuracy. Now in this component, what are the things we will be having? In the B, are we having accuracy?
No, sir.
Accuracy is not there. What about repeatability?
Yes, sir.
Everyone, is it clear? See, what I am asking, is it visible first of all, the circle here?
Yes.
Okay. See here, what is happening? Accuracy is not maintained. Why? Because one part is outside the given region, which means accuracy is disturbed. At the same time, see, the distance between two components, the distance between 2 points is maintaining somewhat from the previous point. Then, which is repeatability. Okay, accuracy and repeatability. Now in this condition, see here in C, what is there? Is it having accuracy? In C condition, is it having accuracy? Is it following the accuracy?
Yes, sir.
Accuracy. The part need to place here, the final region. Is the robot supposed to place the part here?
No, sir. No, sir. No accuracy.
See, finally the robot need to place the component in this gray circle here. In the C, the robot need to place the component here. But in application, what happened? The robot is not at all maintaining that one. So because of which, what will be happened? My accuracy was disturbed. Now what about the repeatability? Is it having repeatability factor?
Yes, sir, there is a repeatability.
Why? Because it is maintaining some plus or minus tolerance and they are at the same direction. I mean, supposed to be at the somewhat direction. So it is maintaining repeatability. Now this one,
No
Both not.
repeatability, no accuracy.
no repeatability as well as accuracy. How can you say that no repeatability? See, these two distances are same, these two distances are same, these two distances are same, these two distances are same. But there is a difference in these two. Because of which, what will be happen? Repeatability is also disturbed, at the same time accuracy is also disturbed. Okay, so finally my robot need to do this A application. Anyhow, my robot need to maintain the accuracy at the same time repeatability. Then only my application will going to perform even after 1000 cycles, even after 10,000 cycles. Okay, so this is the important factor that robot need to follow: accuracy as well as repeatability. Accuracy is nothing but reaching the final position even after 1000 times, even after 10,000 times, that is accuracy. Okay, whereas repeatability is nothing but maintaining that point is nothing but repeatability. Okay, clear?
Excuse me, sir.
Yes.
सर आई थिंक बी पार्ट में एक्यूरेसी है और रिपीटेबिलिटी नहीं है.
Just a second, let me erase. Okay, distance is there, distance is there, distance is there. Okay, fine. Here, there, okay, there is a slight difference in here. So, it is not there. Okay. Here, accuracy and repeatability. Here, accuracy, no repeatability. Here, repeatability, no accuracy. Here, no accuracy as well as no repeatability. Clear? This is what exactly the main concept of repeatability as accuracy. This is one of the important thing in the robot. Even the application, even if you are performing an application, even if you are creating a program, these are the two important things you need to adopt. Why? Because in the first run you are going to perform. So once you have defined the program, once you have created a program by using C, Python or manually, so you have created a program to pick a part from here and to place here. In the initial run, it was running perfectly. Now, which means it is not at all correct. So you have to run this program for even 20 cycles or 10 cycles in a test basis. So that what will be happen? So you have to check whether the final operation which you are going to maintain, that is having accuracy as well as repeatability there or not. You have to check thoroughly. Otherwise, what will be happen if you have checked one application, two applications? If in the both application it is performing well, so you have given this application for 100 number of runs or some 200 number of runs. What will be happen? Maybe after 10 runs, after 20 runs, maybe because of this repeatability or not maintaining the accuracy, maybe what will be happen? The spot you are going to do here will going to come finally at this location. So if you haven't monitored this for the first 20 runs, so to eliminate these things, repeatability and accuracy, you have to run the mission, you have to run the program which you have defined continuously for n number of times. I mean for 10 runs or say 10, 20 runs or like 25 dry runs, so that you will be having clear idea on how exactly the robot is behaving at the final. So whether it is reaching the final position or not, whether it is maintaining the accuracy or not. So even though it is maintaining the accuracy, whether it is meeting the repeatability factor or not, that you can check. Okay. Now what will be happen if at all I'm using a spot welding application? Like in the previous examples I have shown you some videos. In there is a spot welding application. In that spot welding application, here I am going to do the spot welding. So in this operation, so what will be happen if there is no accuracy as well as no repeatability? Here I am going to spot at 20 different points for this complete operation. What will be happen if there is no accuracy as well as no repeatability in the D condition? A, B, C and D. What will be happen if it is having a D? Will I am going to get the final desired output in the D?
No.
Okay. What will be happen if there is a C? In this application, my robot is having only C. Okay, this one C. What will be happen now?
Not acceptable, sir.
Okay. So if it is there, what will be happen?
But we know where the error is, sir. We can correct it. Like there is a repeatability in error.
Okay. So there is a repeatability error, but if it is a one application, two applications, or three runs or four runs, so we can perform. It is a complete. Maybe if it is for 500 number of turns, 500 parts need to be welded here. The n is final n is 500. Now what will be happen at this condition? Is it acceptable?
No, not feasible.
Why? Because see, I want to do a spot welding here. If even though it is not welding, at least it need to do here. But maintain the speed also, maintain the first point and second point is also acceptable. So first point is here, second point here, third point here, fourth point and fifth point should be at this corner. So because of there is a no accuracy, what will be happen? Maybe the weld at this position and this corner was left without having any spot welding joint. So this is a failure. Now what will be happen with this one B condition?
So this is acceptable. It,
B is X. Why? Because see, the robot need to do the welding application here. It is maintaining the ratio. What is happened? Okay. So it should be supposed to do at in and around location only. So I have given this condition, which means the robot need to do the spot welding application here. But in the B condition, what will be happened? The robot is performing the spot in this region itself. Okay. So this is also somewhat what will be happen. So it will be trying to do this application, do this application, do this application. So if what is having the previous application is this, what will be happen with this one? So it is going to do this one. Because of this, what will be happen? This will going to do this one. Like it will be having some delay or some tolerance will be there, some deviation will be there at the final point. The final point need to be valid here, but it should be at somewhere here. But which is acceptable. Why? Because it is in the region of the accuracy only. It is not at all deviating from the given accuracy chamber. It is maintaining the accuracy and it is somewhat deviating from the given. So it is somewhat acceptable. Now what will be happen if it is in A condition?
सर नॉट एक्सेप्टेबल बिकॉज वहां पे पॉइंट प्रीवियस पॉइंट पे ही जाएगा तो फिर वो मतलब क्या बनेगा उसका बार बार
ये कंडीशन में
सर वो 5 पॉइंट वाले में ना
this A, I am asking about this A for this application.
It is a perfect, sir. We have accuracy and repeatability both.
Okay, fine. See, I hope you are clear with this one, repeatability and accuracy. Accuracy is nothing but you have to maintain the final, you have to maintain this point that is called as an accuracy. Best example is spot welding. In the spot welding, they have defined, there are simple, see, there is a 1 centimeter plate here and there is a 1 centimeter plate here. These 2 centimeters plate are going to meet at 0.5. So 0.5 here and it was overloaded here and it will be like this. So which means this is a 1 centimeter and 1 centimeter. This is a 0.5 centimeter line is there. In this 0.5 centimeter line, you have to do the welding operation. I mean, you have to do the spot welding application. Now, what is the, I mean, what is the path you will be having? Just a second. Let me erase all these things. This is the final point, 0.5 centimeter, which means hardly 5 mm, which is very less. This is your rest material. This is your rest material. In this only you have to do the spot. Now, if the area is this much of low, now what is the definitely thing needed? Accuracy is plays a key role here. If the weld is going to happen here, spot welding, it is acceptable. Even though if it was done acceptable. Now what will be happen if it is like this? This is no way acceptable. Even though it is maintaining accuracy, even though it is maintaining repeatability like this at this point itself, which is no way acceptable. That is why A is the maximum condition with which all the robotic engineers will try to perform its operation. So they are going to maintain this tolerance, which means the hardly the spot welding will be 2 mm or maximum of 3 mm. 3 mm of spot weld will be there. Maximum size of the spot weld will be 3 mm. So that what will be happen here? What is the length of this one? This sheet length is 0.5 centimeters, which means 5 mm. So this is 5 mm and the maximum spot is 3 mm. So they are going to take this 3 mm and this 1 mm here and 1 mm here as a tolerance, which means even though if the this weld will comes to this 1 centimeter 1 mm 1 mm, which is acceptable, but beyond that which is not acceptable. So this is how they will going to prepare the program. They are going to maintain this. So they are going to maintain this ratio. Okay, that is why this is plays a key role. Clear?
Yes, sir.
If is apply, see, if my plate is this much, if my plate is having 20 centimeter and the same plate is having 20 centimeter, now here I am having some 10 centimeters of length. Now in this 10 centimeter I can spot weld anywhere here. There are no any limitations. I need to do this type of spot welding. Now at this application, A, B, C, D, is it necessary for A? This much of working area is there. Now I want to do, so whether A is acceptable here or not? A is anyhow acceptable, even though A is not maintaining, but still it is acceptable. Why? Because there is a lot of space here is there. Lot of space is there, because of which what will be happening, even though if it is a 2 mm or 3 mm deviation is there, that is acceptable. Why? Because we will be having that much of freeness here, availability here of material is there. So because of which I am trying to maintain this one. Okay, clear? That is what exactly main advantage of this one. So if the length of the component, if the vehicle, I mean if the component is having some nomenclature, the way component is having some larger in space, larger in dimensions, then even though if it is not maintaining the accuracy or repeatability, sometimes it is acceptable. But if the material is precise, if the material is a particular in size and the size is matters, at that condition we have to maintain this A condition. Okay, now while coming into, now we are coming into drives. which means how exactly we are going to move our robot. So what is the need of this one? So how this robot will be defined, electric will be defined, hydraulics will be defined, all these things will be discussed in this robot drives. Basically the drives are defined in the power source for the robot. If at all the robot tend to move from this direction to this direction, if at all you want to pick in this direction, so how it need to pick? If the weight carrying capacity is 30 kg here, in 30 kg what is the type of fluid I need to use, how can I supposed to pick it, all those things we can be discussed in this drives. See, first one is hydraulic drive. Provide fast movements, preferred moving heavy parts, preferred to be used in explosive environments, occupy large space area. There is a danger in oil and the shop floor. These are the some of the advantages as well as disadvantages of the drives. In the drives, what will be happen based upon the end application? So if your end application is a 50 kg, 60 kg or greater in weight or heavy parts that need to be lifted at that application, so even though if you use a motor, what will be happen? There is a wear and tear of electrical components inside it, a wear and tear of gears that will be involved in it. So because of which you are going to use some hydraulic component, with which what will be happen? All you need to do is you need to pressurize the oil and you need to give it to the piston and cylinders and you need to operate it. So automatically this component can do in operation in a smoother manner, in a slower manner. That is why if it is end application is a higher, end application is a more, then we are going to use this hydraulic drive. In this there will be having limitations like large space area is needed. Why? Because if the robot is picking some 30 kg or 40 kg of load, then automatically the robot size is that much of bigger, and the load, the work envelope is also that much of greater in that applications. If that much of load is there, if the robot is going to pick some 50 kg or 40 kg of load, then obviously the robot cylinders, the piston and cylinders that will be used to lift this arm, that also will be in a greater size. So that what will be happen, there will be a lot of space that also be needed for picking this one. At the same time, if at all you're using some hydraulics as well as all these things, then there definitely there will be some leakage of oil by the from the pipelines, and there will be having oil storage, dispose in these areas. So that also you need to consider in the drive. Next, coming to the electrical drive. Drives comes with this one: slower movement compared to the hydraulic robots, good and small for the medium sized robot, better position and accuracy, repeatability, stepper motor, one loop control, DC motor, closed loop control, cleaner environment, most used type in the drive in the industry. So like I said, so if it is a heavier application, we are going to use this one. If it is a moderate application, which means if the speed, if the weighing capacity is in between 5 to 10 kg or 5 to 20 kg, in this application we are going to use, we can use these electrical motors. Whether it may be a servo motor or a DC motor, based upon the end application, we can go for this robot. Why? Because the end application, if it is a 10 kg application, then automatically I can use a somewhat bigger robot. So not a robot which is having 30 centimeters or 40 centimeters in size. If it is having 10 kg of load, then automatically I will be using some 100 centimeters or a greater size of robot. So that what will be happen, because of the higher torque or because of the higher K load in that motor, so it can perform up to some extent. So I can perform the moderate application. This electrical drive can operate up to some extent. It is having cleaner environment, most user type in this industry. Now while coming into this one, pneumatic drive. Pneumatic drive is mostly used for the preferable for smaller robots, less expensive than electrical and hydraulic, suitable for relative less degrees of freedom, suitable for pick and place applications, relatively cheaper. Here, I hope I explained you. Pneumatic is nothing but we are working with air here, air as a medium. So in this, what will be happen? I will be using a simple compressor, and because of the compressor, I will be creating some pressure in the air. So I will be giving it to the robot arm or robot end application. If at all end application is picking a part whole with a vacuum, so in this application I will be using vacuum as a medium. So based upon the end application, or the end application is less, then I will be using this type of robots, these type of drive systems for moving of the robot as well as moving of the grippers. Okay. Yes. Now coming into sensor, one of the important topic, sensors. Okay, in sensors, robot is having some sensors inbuilt, and some will purchase our sensors, some will add additional sensors. So based upon the end application, see, all these robots will work with respect to the end application only, and what application you are going to perform, what is the type of application you are performing. So that will define your complete robot. Okay, some will be using robot for the inspection purpose, some will robot to do the separation, which means if there is a just like potato manufacturing, not chips manufacturing company is there. In that, what will be happen, different size of potatoes will come from a conveyor. Okay, in that there are some robots that will pick the material, that will pick the larger potatoes, and they will be placing on a separate conveyor, and they will be placing smaller potatoes in some other conveyor, they will be placing the medium conveyors and pick and place on the some other. How this will be happen? Because of the vision systems that will be involved, because of the sensors that will be built on this robot, they will automatically detect based upon the size, based upon the program which I have given, and automatically it will do the application. That is the necessity of the sensors. Some will be using sensors as for sound also. So maybe some part is coming from a conveyor and it will going to fall on another conveyor. So once the part was reaching this conveyor, which means once it was fallen from this height to this height, then there will be having a robot here that will be having a vision sensor. So that what will be happen, whenever a component was fall in this one, there will be some decibels of sound was produced, and this robot is as having a vision sensor, and it was programmed with a code like, so after hearing some decibels of sound, which means if the normal environment is having some 0.5 decibels, so if it is having zero point 0.6 of sound, then automatically the gripper or the hand will go to reach to this location and it will pick a path. So I can define these type of programs also. So that can be possible with the sensors only. That is one of the important thing for this one. Sensors are different, classified into three different types: tactile sensors, voice sensors, vision sensors. Sensors provide feedback to the control systems and given feedback to the flexibility. Such sensors are visual sensors and useful for building more accurate as well as intelligent robots. The sensors can be classified. Okay, so this is what exactly the sensor classification is. Now I am going to explain each and everything here. Sensors. Okay, in the sensors part, there will be having tactile sensors and non-contact sensors. Tactile sensors also called as a contact sensors and non-contact sensors. Here these two are different things. Okay, these will be subclassified into internal sensors as well as external sensors. Internal sensors is nothing but the robot. When you are purchasing a robot, just a second guys. Sorry. Yeah, internal sensors and external sensors. If you are purchasing a robot, then what will be happen, some sensors are inbuilt, some sensors are already there with the robot. Those are called as internal sensors. Some sensors, if at all based upon your end application, if at all you want to add some additional thing, then we will call as the external sensors. In the internal sensors, we will call as a touch or contact sensors. These sensors will work when there is a, some sort of additional touch will be there or additional contact will be there, then these sensors will comes into existence. Okay, these will be subclassified into touch, force as well as position displacement sensors. Touch sensors is like, just a second. Okay, so we'll be having these things. Now I will be explaining you by using this one. Okay, this is called as a contact sensors, whereas in non-contact sensors these are additional, which means there is no need of any contact here. Okay, now see here, tactile sensors. Tactile sensors are provide the robot with capability to respond the contact forces between itself and other objects with the work volume. Tactile sensors can be classified into two types: touch sensors as well as stretch sensors or force sensors. Touch sensors are like, or simply indicate the whether the contact has been made with an object. A simple micro switch can be used for the touch sensor. Stretch sensor is used to measure the magnitude of the contact force. Strain gauge is used for this one. Now, touch sensor is like, if the robot is there, okay, and my environment is completely automated environment. Now what I need to do, I have given a program. So what will be happen, if there is a no sensor, this type of sensors, what will be happen, automatically the robot will start its operation. Even though if you place an hand here or if something was placed on this one, which means the robot itself is having some weight. Now I have placed an hammer here or a tool here and I am working something, and removing this tool, I have forgotten to remove this tool, and I have given operation, I have given the cycle, I have run the cycle. If there is no any sensors will be these type of sensors, then what will be happen, automatically the robot will start doing its operation, because of which what will be happen, this tool will going to fall and some damage will going to happen to the workpiece or someone who is present at that area. So to eliminate those things, the robot will be having some touch sensors as well as stress sensors. In the touch sensor, what will be happen, the robot is having some values, I mean some x y z, some alpha beta gamma a b c, like itself it having some nomenclature involved in it, some 30 to 40 nomenclature it is having. Now if additional force is having, if additional impact is also having in this one, then automatically what will be happen, the robot is given to the feedback to the control system. In the control system where we are operating the program, in which there will be an error, like proximity sensor or touch sensor is enabled, or there is an error in here. So that what will be happen if this was enabled, which means there is something that is up that is touching the motor or touching the robot, or something that is provoking the robot motion, that will be defined with the stretch sensors. Stretch sensor is used to measure the magnitude of the force, which means if there is a just what how exactly I'm going to explain. Mm, yes, sudden impact. If the robot is there, suddenly it is going to touch a wall or something. So if this was happened, so after reaching some speed, automatically the robot will stop. Okay, if suddenly I touched the robot with some with some speed, I mean with some stress, I have tapped the robot, okay, on my own. So like the slapping, what will be happen, I have forcefully tapped the robot like this, automatically the robot will stop. Why? Because there is some additional force, there is some additional stress that will be absorbed by the robot, that can be monitored with these sensors, as used to measure the magnitude of contact force, strain gauge. Generally these are used for the accidental only. So if the robot is going to, I mean, is meeting with some particle or some wall or some abstract, then what will be happen, it will collide with something. So because of the collision, how much force it will be happened of the initial, at the initial speed, after meeting, if the robot is having one, okay, one is the maximum figure. If it is reaching more than one, even 1.1, also robot itself is stopping, its come to its original position, or it will be stopped instantly because of the change in this one. Okay, that is what exactly these sensors. Proximity sensors are used to sense the object close to the near object. Same, these are all doing the same application. If there is an obstacle that is going to this on the robot, the proximity sensors would be located near end of the end effector. This sensing capability can be engaging the means of optical proximity devices, eddy current proximity, magnitude field. So these will be used for eliminating the accidents, eliminating the collisions. Why? Because if the robot is moving something and there is an obstacle here, it will predict, so it will be having some sensor value. So if it is beyond this one, if it is reaching beyond this one, automatically it will give feedback to the control system, and automatically there will be an error, there will be emergency stop that will be engaged on this controller. So automatically the robot will be stopped at the initial position. If there is this one, if the distance between these two was 10, okay, 10 centimeters, if it is moving beyond this 10 centimeters, automatically the sensor will detect this one, and it will give instantly feedback. This all will be happening in a microsecond. In the microsecond, what will be happen, even the distance between these two is 10 centimeters, while coming to 9 centimeter, 9.5 centimeter itself, the robot will instantly stop, because of there is a deviation, or there is an obstacle, there is an rise in the this factor. Those can be optical proximity devices, eddy current, there will be electromagnetic devices that will be defined, I mean, prefixed on those things. Those are used for this collision detection. Some will be like a position sensor. Position sensor is like, if the robot tend to move from one direction to another direction, how much direction it was moved, so what will be the maximum display, what is the maximum distance it has covered, so how much it will be reached. So all those things can be defined by using these position sensors itself. This is a inbuilt sensor, so with which what will be happen, for each and every arm there will be a position sensor, so that I can detect the motion, I can detect the movement, I can detect where exactly my robot will be. So if my fourth arm is at this third, first arm, second arm, and third arm is at this one, and fourth arm is at this location. Now what is the degrees of this one? If at all there is a sensor, automatically I can calculate what is the degree. Initially it was 0, now it was beyond this one, minus 15 or minus 20 is the maximum, that I can detect by using this position sensor. Range sensors are the distance that measure distance from reference point to the other points. Importance. Range sensor is for the just like a displacement or distance calculation. Initially, my home is at this position. In the top view, my home is at this position. Now, finally, I have reached this position. So, I want to calculate this one. Then I can directly use this one. With respect to angle, I can calculate. With respect to distance, if at all I want to calculate with respect to distance, then I mean there will be some inverse kinematics as well as forward kinematics. If at all I want to calculate the inverse as well as forward kinematics, then these type of range sensors will plays a key role. Why? Because itself, because of the position sensor I will be getting theta value, because of the range sensor I will be getting distance, that is centimeters or mm. I can calculate it with respect to range sensors. This is an additional thing. Next one is velocity sensor. With what velocity the robot is moving. So how much velocity it is maintaining. After picking a component, what will be the velocity of each and every arm at the maximum conditions or at the higher conditions at the maximum picking load. So what is the robot velocity, that can be defined with the velocity sensors. Okay. Voice sensors, just like I have explained you, voice sensor is for voice command. Voice programming can be defined by oral communications as well as robot to machines. The robot control is equipped with a speech recognition. So based upon this voice sensors, so what is the type of application you can adopt? Like I already explained you, if there is a component that is falling from some height, based upon this sound, so the robot will come to its position and it need to pick the part. So based upon the application, we can define this the voice commands. So what is the type of thing that will be, whether it may be a word, whether it may be a sound, whether it may be some disturbance. So based upon that, we can define these voice sensors. Vision sensor, voice sensor. Okay, vision is for like a inspection purpose. Computerized vision system will be important technology in the future. Automated robot vision is a more made of possible means a video camera, sufficient light source, camera programmed. The camera mount is on the robot fixed position above the robot in the field of vision. The computer software enables in the vision system. Same thing. So based upon your end application, if the end application is for inspection, which means there will be a camera, there will be a vision system, there will be a UV protection, there will be X-ray that will be fixed on the robot end arm. So it will be giving, it will be like this. So whenever a component is falling through this one, automatically it will be collecting. Just like an example. In the inspection, what will be happen once the part was prepared, once the component was labeled, it was packed, automatically what will be happen, there is a label that will be defined here, and there will be a barcode here that is stick to this one. So there is a, these things will definitely follow through the conveyor. Here there is a robot here, that robot will be having some scanning system, some vision system that will be here, and there will be a continuous follow of this one, there will be a range. I mean the range is like a 20 centimeters. Up to 20 systems it will automatically detect. So whenever this component comes into this one, so automatically this component comes here, and there is a this barcode. Instantly, because of this vision sensor, automatically it will detect this one, or it will, by the using some UV based upon the scanners, it will detect this one and it will collect this. I mean it will give the information to the computer, and it will give an information to the control system based upon the program which they have defined. Just like this one, vision sensors will be used. Okay, where we are reaching. So this is what exactly. Okay, sensors: tactile, contact sensors, non-contact sensors, touch sensor, force sensor, position distance sensor. These are all inbuilt sensors that are defined in the robot. Whereas when coming to this one, additional sensors, if at all you want to calculate the, I mean if at all you want to work the robot with respect to voice, then it is like this. If at all you want to work the robot with respect to vision, then definitely you are going to work this. Like already said you, if at all you want to calculate something, or which means the velocity thing, all the things, range, how much displacement it is happening, if at all you want to calculate directly the data as well as centimeters, kinematics as well as dynamics directly, so that you can go for the range sensor as well as proximity sensors. These are the additional sensors. Apart from this, there are a lot of sensors that are in the market. You can improvise the, for improvising the work, for improvising the robot motion, all those things, they will be having lot of sensors. Those sensors will comes in this external only. These are the inbuilt sensors that will comes with the robot, where the touch sensor is used for the touching, or if the robot is having additional contact, then to detect this one, touch sensors will be needed. Force sensor is like if the robot is going to collide something with some force, so this is called as a force sensor. So what will be the force, how much force it will be reaching, after reaching certain speed, what will be happen to this one, that can be defined by the force sensor. Position as well as displacement is like, so how much position it has reached, what is the position of each and every arm, so what is the theta, so how much displacement it has covered, all those things will be defined in this one. Okay, where are we? Now grippers. In the grippers, like already told you, this we have discussed in this one. This one. Here there are some of the grippers that will be defined here: mechanical gripper, vacuum gripper, magnetic gripper, adhesive hooks, scoops, and other four, based upon the end application. Like said, these are the mechanical grippers, which what will be happen by using different links and joints, by using different kinematic joints, we can hold the component. So these are all called as the mechanical grippers. So if you are using a vacuum or suction, which means if you are using compressor, pneumatics, then these are the type of grippers that we'll be using. So they are going to inject that part here, and automatically they will be reverse sucking it, so that the part will automatically pick here. So if at all I pick these things, if at all I pick these cardboard components with some mechanical grippers, then what will be happen? There will be a delay, there will be a hole, there will be a dent that will be going to perform on this one. So that is vacuum. Third one is a vacuum grip, I mean magnetic grippers, based upon the end application. If the material is somewhat stainless steel or somewhat magnetic in nature, and I need to have some surface finish also, perfect surface finish also, and the component size is somewhat mm, lighter, then at that component, then I can use this type of magnetic as well as electromagnetic things, so that what will be happen, I can directly pick the component based upon this electromagnetics as well as magnetics involved between these two things. I can pick the component and place it somewhere. And adhesive grippers. Adhesive grippers is like a glue as well as some soft grippers. Whereas we can pick the components like this. See if it is a glass like thing. If it we can where the application is preferring not vacuum also. I mean this pneumatic also. At that application, special applications, we are going for the adhesive grippers. Where the drawing applications, somewhat special applications that are needed for this adhesive. And finally, if it is a mechanical component and there is no need for these things like grippers, there is no need for the dent as well as picking a scrap. For those things, we are using these type of hooks as well as scoops. Hooks are supposed to be at this hinge support, sliding mechanism, double side. All these things will be used in the grippers based upon the end applications. Okay. uh, these things, okay, regarding kinematics and forward kinematics, I will be discussing you tomorrow session. Okay. Any doubts so far in today's session
No,
regarding
sir.
the robot nomenclature, regarding the robot sensors, all these things clear?
Yes, sir.
Okay. In tomorrow's session, we are going to discuss about forward as well as inverse kinematics. Why? Because it's an important topic and as well as a lengthier topic. I hope you know this forward as well as inverse kinematics. For what purpose you are going to use this one? For what purpose you are going to this one? So if at all I have this one and I want to calculate this, how exactly it need to be? If at all I have this and I want to calculate this, how exactly it will be? Where these applications will be used? Where these applications will be used? All those things will be discussed in this page in tomorrow's session. After that, programming. So if at all I want to program the robot, then what are the different types? And each and every types, what are the limitations and what are the advantages? After that, in tomorrow's session, we are going to discuss about the applications. So what are the different applications with which the robot will be used, and advantages and disadvantages, all the things we are going to discuss. And we are going to end this basic session tomorrow. Okay, clear?
Yes, sir.
See, if you're having any doubt in today's session, don't worry. Just note it down all these things, and you can ask me tomorrow. So if you're having any doubt, clear?
Okay, sir.
Okay, fine. Chalo then have a great day. Bye, guys.
Okay,
Thank you,
sir.
sir.
Okay.
असाइनमेंट कब तक देना है सर वो?
कल लास्ट है, कल मैंने बोला ना असाइनमेंट में कल शाम को लास्ट है.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah, thank you.